Good morning, my dear students. Welcome to my physics class. Look at the pictures below. Here, 5 kg rice. This boy is saying its weight is 5 kg, and the girl is saying its mass is 5 kg. So, which one is correct? Its weight is 5 kg or its mass is 5 kg? Which one is correct? In physics, 5 kg expresses the mass of the rice. Weight and mass are two different quantities. So today's topic is mass and weight. Mass, its Bengali meaning is bhor. The amount of material present in an object is called its mass. It is denoted by m and its SI unit is kilogram, and it is written as kg. Here iron ball, and it is 6 kg, that is its mass is 6 kg, means the amount of iron in this ball is 6 kg. That is, mass means the amount of material present in an object. This object is made of iron, so amount of iron is the mass of this ball. Here amount of iron is 6 kg. That is, we need 6 kg iron to make this ball. Therefore, its mass is 6 kg. So, mass is the amount of material. And here plastic ball, and it is 200 gram. So, the amount of plastic in this ball is 200 gram. That means the 200 gram plastic is needed to make this ball. So, its mass is 200 gram, that is amount of plastic. So, amount of material present in an object is the mass of the object. From Newton's second law of motion, we know F is equal to ma, that is force is equal to mass into acceleration. Here m for mass and a for acceleration, and F for force, that is force is equal to mass into acceleration. And from this equation we can write m is equal to F divided by a. Here m is equal to F divided by a, that is, we can say mass is the ratio of force and acceleration. And also we can write acceleration is equal to force divided by mass. From this equation, if m increases, then a will be decreased. That is, with increasing m, a will be decreased. So, the heavier body resists to change its velocity. If we apply same amount of force on two bodies, one is heavier and another is lighter, then acceleration will be produced more for lighter body and acceleration will produce less for heavier body. So, mass is the measure of inertia. Inertia means jarota, that is, every body tends to retain its own state of motion, that is rest or motion. So, if we want to change the state, we have to apply force, otherwise it will not change its state of rest or state of motion. The rest body tends to retain its rest state and moving body tends to retain its motion. This property of the material or body is the inertia, and for heavy body inertia is more and for lighter body inertia is less. Therefore, mass is the measure of inertia. If you want to change the velocity of a body, the heavier body resists it more than the lighter body. Now weight means oজন. The force by which earth attracts an object towards its center is called weight. It is denoted by W and its SI unit is Newton. In our practical life, we do not make any distinction between weight and mass, but weight and mass are two different things. Mass is the amount of material present in an object, but weight is the force. It is one kind of force, and mass is amount of material, but weight is one kind of force. Which force? The force applied by earth on the body. The force applied by earth on the body is the weight of that body. Therefore, the force by which earth attracts an object towards its center is called weight. We know in this universe everybody attracts each other. So earth attracts everything towards its center, and the attraction force by which the earth attracts a body towards its center is the weight of that body. So weight is actually force, the amount of force by which earth attracts an object towards its center. We know the unit of force is Newton, therefore the unit of weight is also Newton, because weight is one kind of force, therefore its unit is also Newton, and weight is denoted by W. And measure of weight is equal to mass into acceleration due to gravity. We know that F is equal to ma, and here attraction force is gravitational force, therefore instead of A we use G, acceleration due to gravity. This acceleration is acceleration due to gravity. So W is equal to W means force is equal to mg. Here a iron ball, its mass is m, and earth attracts this ball towards its center, and this is the direction of attraction force, that is earth attracts this ball towards its center, and amount of force by which the earth attracts this ball is the weight of this ball. Here attraction force is F, that is earth attracts this ball by the amount of force F. So its weight W is equal to F is equal to mg, because we know F is equal to ma, here F is equal to mg, because here force is gravitational force. So instead of A we use G. So W is equal to F is equal to mg. Weight of the body is mg. So mass is the amount of material and its unit is kg, and force is weight is one kind of force and its unit is Newton. Therefore weight and mass are two different quantities. Mass is a fundamental quantity and weight is derived quantity. Now mathematical problem. The mass of an object is 50 kg. What is the weight of it? If we know the mass of a body, we can determine the weight of that body. From the mass of a body, we can determine its weight. Now solution. At first we will write the data given in this math. Here mass is given and mass is equal to 50 kg. If this mass is given in any other unit, gram or any other unit, then we have to convert it in kilogram. And here acceleration due to gravity, we know standard value of acceleration due to gravity g is 9.8 meter per second square. We know there are many values of g, and standard value is g is equal to 9.8 meter per second square. So here 9.8 meter per second square. Weight is equal to what? we have to determine the weight of this body. We know W is equal to mg. This is the formula of weight. M is equal to mass and g is the acceleration due to gravity. So it is 50, m means 50 and g means 9.8. So after calculation it is 490 Newton, and we know unit of weight is Newton, so it is capital N. So this is the answer, that is the weight of the body of mass 50 kg is 490 Newton on the surface of earth. Relation between mass and weight. We know weight is equal to W is equal to mass m into acceleration due to gravity. This is equal to W is equal to mg. We know it, weight W is equal to m into g. So weight depends on mass of the body m and acceleration due to gravity g. Here weight is equal to mass into g. So weight depends on mass of the body and acceleration due to gravity. But for a fixed body, m is constant. M is always constant. M does not depend on, that is mass of the body does not depend on location, place or any other thing. Therefore, everywhere mass is constant. Suppose a ball is made of 6 kilogram iron. If we take it on the moon or any other planet, then it will remain 6 kilogram and its mass will not be changed. If we take it from Dhaka to London or from Dhaka to any other countries, then its mass will remain same. So mass is constant for a fixed body. But acceleration due to gravity is not fixed everywhere. It varies from place to place. And therefore weight of a fixed body depends on g only, because m is constant always. It does not depend on any other thing for a fixed body, and g varies from place to place. The value of g is different from place to place. So at equatorial region the value of g is 9.78 meter per second square. At polar region g is equal to 9.83 meter per second square. But weight depends on g. As g varies, so weight will vary. The value of g at the surface of moon is equal to 1 by 6 into 9.8. This is the value of g on the surface of earth. If we divide the value of g on the surface of earth by 6, we will get the value of g at the surface of moon. So the value of g at the surface of moon is 1 by 6 into value of g at the surface of earth, and after calculation it is 1.633 meter per second square. This is the value of g at the surface of moon. So the value of g is not constant everywhere. It depends on location, place, country, planet to planet. The value of g will be changed. So the weight of an object at moon is equal to 1 by 6 into weight at the surface of earth, because weight depends on g, as g is equal to 1 by 6 into 9.8, that is 1 by 6 into g on the surface of earth. Therefore the weight of an object at moon is equal to 1 by 6 into weight at the surface of earth. So it will be 1 by 6 of weight of the body at the surface of earth. The weight of a body increases in proportion to its mass. The weight of a heavier body is more than the lighter body. So if mass is increased, then weight will be increased. Therefore the instrument which are used to determine weight can also be used to measure the mass of the object. As weight increases with increasing mass. So the instrument which is used to determine weight can also be used to measure the mass of the object. Often spring balance is calibrated in units of kilogram. Balance and weighing instruments are calibrated in such a way that we sometimes use the kilogram unit for measuring both mass and weight. That is, for both measuring mass and weight we use kg, that is kilogram unit, but it is wrong practice because the weight of unit of weight is Newton and unit of mass is kilogram. But if we know the mass of the body, we can determine the weight of that body by multiplying it 9.8. And here weighing machine, and here spring balance. Here spring balance is calibrated by both Newton and gram unit, that is, it is unit of weight and it is unit of mass. So this spring balance is calibrated by Newton and gram. Here Newton unit and here gram. Now the variation of weight with the variation of acceleration due to gravity. We know weight W is equal to mg, and m is constant for a fixed body, but g is not constant, g varies from place to place. Therefore weight also will vary from place to place. So now we will discuss about variation of weight with the variation of acceleration due to gravity. A, at different places on the surface of earth, that is, we will discuss the variation of weight at different places on the surface of earth. If the object is on the surface of the earth, then the value of g is equal to gm divided by r square. We know it, the value of g is equal to gm divided by r square. Here g is capital G, gravitational constant is a constant, capital M, mass of the earth is also constant. So acceleration due to gravity depends only on the radius of the earth. So on the surface of earth, the value of g depends on radius of the earth only. But our earth is not a perfect sphere. For the shape of the earth, our earth is not a perfect sphere. So everywhere the radius of the earth is not same. That is, at different places the value of r is different. As the value of r is different, so the value of g will be different. And we know at the polar region the value of r is minimum, and at the equatorial region the value of r is maximum. So polar region, at the polar region r is minimum. When r is minimum, g will be maximum. With increasing r, g will be decreased, and with decreasing r, g will be increased. At the polar region, radius of the earth is least. Therefore here the value of g will be maximum. And at the equatorial region, the value of r is maximum. Therefore the value of g will be minimum. So here at equator the value of g is minimum, and at polar region g is maximum, because here radius is minimum and here radius is maximum. So if we move from equatorial region to polar region, then the value of r will gradually decreased. Therefore the value of g will be gradually increased. If we move from equator to pole, then the value of r will be decreased. Therefore the value of g will be increased. And we know at the equator g is equal to 9.78 meter per second square. This is the minimum value of g on the surface of earth. And at polar region g is equal to 9.83 meter per second square, and this is the maximum value of g on the surface of earth. So here the value of g is minimum, so weight will be minimum. At the equatorial region, weight will be minimum because weight depends on acceleration due to gravity. And here polar region, G is maximum, so weight will be maximum. At polar region weight is maximum, and at equatorial region weight is minimum. So weight is maximum at polar region and minimum at equator. Number 2, for the diurnal motion of the earth. We know the earth rotates about its own axis and it takes 24 hours for on rotation. This is the diurnal motion of earth. Due to this diurnal motion of earth, the acceleration due to gravity gradually increases from the equatorial region to the polar region. Due to the effect of this diurnal motion of earth, the value of G gradually increases from equator region to polar region. That is, due to this rotation, the value of G gradually increases from polar region to equatorial region to polar region. The value of G will be increases gradually from equatorial region to polar region due to the effect of this diurnal motion. So in this case also the value of G is maximum at polar region and minimum at equatorial region. We know for the shape of the earth, the value of G is maximum at polar region and minimum at equatorial region, and due to the diurnal motion of the earth, the value of G is also maximum at polar region and it is minimum at equatorial region. So if we move from equatorial region to polar region, the value of G will be gradually increased. So as a result, the weight of an object also increases as we move from the equatorial region to polar region. That is, if we move from equatorial region to polar region, then the value of weight will be increased with increasing the value of G. Now B, for the increase of height from the earth's surface. Now the effect of height on the weight. Here earth, the center of the earth, and here m is the mass of a body, and from center of earth, that is from center of the earth to the body distance is d, and m is the mass of the earth. So acceleration due to gravity G is equal to gm divided by d square. That is, acceleration due to gravity depends on distance d. If d is increased, then G will be decreased. For this value, that is when d increases, G is decreased. The value of G decreases with increasing height from the surface of the earth. So if we move from higher distance from the surface of the earth, that is from surface of the earth, if we move in higher height, then the value of G will be decreased gradually. That is, with increasing height, the value of G decreases. Because the greater height from the surface of the earth, the lower is the value of the weight of an object. So weight will be decreased if the height is increased. Thus the value of G is less at the top of a mountain, as the weight is decreased with increasing height. So at the top of the mountain, the weight will be less. At a point inside the earth. Now here earth and m is at inside the earth, and as we go deeper inside the earth, the value of the acceleration due to gravity goes on decreasing. If we move deeper to deeper, then the value of G will be decreased. So at the surface of the earth, the value of G is maximum. If we move higher height, then the value of g will be decreased. Also, if we move deeper at a certain depth, then the value of g will be decreased. So maximum value is on the surface of earth. If we move in this direction, then the value of g will be decreased, and also if we move in this direction, then the value of g will be decreased also. So at the surface of earth, the value of g is maximum. Because of this, weight of an object goes on decreasing as we go deeper and deeper inside the earth. That is, if we go deeper and deeper, then the value of g is decreased, and therefore weight is also decreased. And if we move, and at a time it will be decreased, and at the center it will be 0. From surface of the earth, the value of g is gradually decreased, and finally at the center of earth g is 0. That is, there is no attraction at the center of earth. Thus, the weight an object is less inside a mine. At the center of the earth, the value of the acceleration due to gravity is 0. So at the center of earth, value of g is equal to 0. Then what will be the weight of the body at the center of earth? At the center of earth, g is equal to 0, that is, acceleration due to gravity is 0. Therefore, mass m into 0 is equal to 0. The weight of the body will be 0 at the center of earth. Therefore, if we take an object to the center of the earth, there will be no force of attraction of the earth on the object, and its weight will be 0. So at the center of earth, the value of g is equal to 0 and weight is also 0. Now evaluation, the value of g at equator is equal to what? We know this is 9.78 meter per second square. The value of g at polar region is equal to what? It is 9.83 meter per second square. The weight on object at the center of earth is equal to what? 0. We know the weight of an object at the center of earth is 0. Now your homework. The mass on object is 40 kg. What is the weight of it at the surface of moon? My dear students, try to calculate this. What is the weight of the object at the surface of moon? And its mass is 40 kilogram. Thank you very much.